In this video, we'll talk about the algebra of continuous functions. So we have seen in the last few videos that limits dictate continuity. Whenever you have to figure out whether a function is continuous or not, we leverage limits. This means the algebra of limits dictate the algebra of continuity. Whatever works in the world of limits also works in the world of continuity. Just like the case in limits, we can add, subtract, multiply and divide the limits. We can also add, subtract, multiply and divide functions to get their continuity. For example, if fx and gx are continuous at a point c, if for x equals to c, we have these two functions and both of them are continuous, the algebra of continuity says that we can add these functions and whatever we get is still continuous at x equals to c. So fx plus gx, that's also continuous. This works for subtraction, multiplication, division, all four of them. So the sum is continuous, the difference is continuous, the product is continuous, and the ratio, the quotient, that's also continuous. There's just one exception for the last part. Just like everywhere else in the math world, you can't divide by 0. So this works provided g of c is not equal to 0. The denominator is never 0. And we have seen this in the chapter functions. When we add these two functions, we can write this as f plus g. That's a new function, f plus g. This is f minus g, this is fg, and this is f by g. These are just notations. So let's prove one of them. Let's prove the first one. Limit x approaching c, f plus g x. What is this equal to? So this is equal to limit x approaching c, fx plus gx. This is by definition. We can split the limit. We can say that this is equal to limit x approaching c fx plus x approaching c gx. And because these two functions are continuous, we can say that this value should be equal to f of c and this value should be equal to g of c. So this is equal to f of c plus g of c. Now we can add them. We can say that this is f plus g of c. Let's write the rationales as well. This is equal to this by definition. This is how we have defined f plus g. The same is the case here. This is how we have defined f plus g. This means we are adding these two functions. This part where we spread the limits, we can say this by theorem on limits. We have covered this in previous videos. And this part is given in the assumption. We have assumed that these two functions are continuous. This means their limit exists and that's equal to the value of the function at that point. So we can say this as f and g are continuous functions. And we can prove a lot of interesting things using the algebra of continuity. For example, this statement. Prove that every rational function is continuous. We know that polynomial functions are continuous. Every rational function is also continuous in its domain, of course. So quick refresher on what rational functions are. They're just like rational numbers. So rational numbers are p by q, where p and q are integers and q is not equal to 0. Rational functions are px by qx, where px and qx are polynomial functions and qx is not equal to 0. So can you see how we can use algebra of functions to prove that rational functions are continuous? Okay, let's do this together. Px by qx, we have a ratio here. We're dividing one function by another. So we can use the fourth point. Fx by gx is continuous at x equals to c if fx and gx are both continuous. But we also have to mention that this is true when gc is not equal to 0. We can't have the denominator 0. Okay, so their ratio is continuous if each of them independently is continuous. That's exactly the case here. Px and qx are polynomial functions. And because polynomial functions are always continuous, we can say that their ratio, which makes rational functions, is also continuous. So this proves that all rational functions are continuous in their domain. Here's a quick problem. Is fx equals to x square minus sin x plus 5 continuous at x equals to pi? Pause the video, think about it. Okay, so we can do this the old-fashioned way. We can find the left-hand limit and the right-hand limit and the value of this function. Or we can use what we have just learned, the algebra of continuous functions. We can split this function into 3 parts and check the continuity of each of them. So if we split this, we have x square, which is continuous at x equals to pi because it's a polynomial. We have sin x, that's also continuous because this one is also continuous throughout. And we have a constant function. This is also a polynomial. This is continuous at x equals to pi. So all three are independently continuous. This is a polynomial, this is sine, and this is also a polynomial. So all three are continuous. This means their sum will also be continuous. So we can say that fx, that's the sum of x square minus sine x plus 5. This is also continuous at x equals to pi. Here's one more. What if we add, subtract sine x and cos x? Sine x plus cos x, sine x minus cos x. Let's also multiply and divide them. Sine x times cos x and sine x by cos x. So here are these functions. Which of them are continuous? Which of them are not? And if they are not, where are they not continuous? Pause the video, think about it. Okay. So sine x and cos x are independently continuous throughout. We can say that f plus g, their sum, is also continuous. F minus g, that's also continuous. Fg, this is also continuous. And f by g, this is also continuous except when the denominator is 0. So this is continuous wherever g is not equal to 0. Let's have a closer look here. What's the denominator? That's cos x. So this is continuous except at places where cos x is 0. And where is cos x 0? Cos x is 0 for all odd multiples of pi by 2. Think about it. Cos of pi by 2 is 0, cos of 3 pi by 2 is 0, cos of minus pi by 2 is 0, and so on. And it's not 0, it's 1 or minus 1 for all even multiples of pi by 2. Cos 0 is 1, cos pi is minus 1, cos 2 pi is again 1, and so on. So you have to exclude these values. So let's write that down. So this is continuous forever except these values, except when x is the odd multiple of pi by 2. And how do we write odd numbers? We'll write 2n plus 1. Here n belongs to the set of integers. So whatever integer we pick, double of that will be even. Adding 1 will give us an odd number. So this ensures that we have an odd multiple of pi by 2. So all values of x except these ones will give us a function sin x by cos x which is continuous.